Okay, no more time. So here, just wanted to illustrate that with machines, it's now faster for us to do these tasks automatically. So on the right, you can see that I got this information from an AI tool. So here, it mentions that it has approximately 3 to 4 apples. So imagine if you had to do it manually, you'll need like more than 2 seconds. So that's how amazing technology has been. Okay, so just similar to like what I mentioned a while ago, 9 years ago, I was a management trainee. And as a management trainee, I got around to like the different
Boleh
functions. So
diganggu
now I
sebentar
have
nggak
a
sih? Mau
more
ngasih mic.
holistic approach, meaning I know a little bit about operations.
Need to microphone.
Oh,
Mic you.
Can you
Okay.
just put
you.
here. Okay, hold on there. Okay. So I knew about operations, finance, customer service, and a little bit of tech. So just so you know, as a BD or a business development sales associate, I needed to negotiate with clients and do like a lot of price checks. And back then, like almost a decade ago, it was really manual. Like I had to copy paste every single information on a website, and that would take me like around 2 days. And I had to do this weekly because I knew that even though this task was so tedious, it was so important because it helped with the growth of the category and the team. That's why I thought to myself, okay, I can't do this manual work forever. I need to come up with a data scraper. So I went talking to our tech team, asking them, hey, can you create a data scraper for the team so that we can utilize this for price checks? And they went back to me and they said, oh, we don't have any bandwidth for this. So this gave me the opportunity to create my own data scraper. And as far as I remember, on the back end, what I used here is Beautiful Soup and other libraries. So yeah, so instead of like 1 to 2 days of working on this manually, because of the script, it has now reduced to around 4 to 6 hours. So imagine like a lot of savings from this automated task. So here's like a preview of like how the framework worked for the data scraper. So I first created the data scraper for like one website, and when that worked out, I created multiple. So one thing to note is that for data scrapers, you have to custom build it for the website, meaning you have to like really analyze the elements in order to create this. So whenever the website would change like an element or a format, you'd have to update it or else your scraper won't work. Another thing to take note of is that you have to properly throttle your requests or else it will overload the system of the website of the place you're scraping from. And from there, it would output like a CSV file. So because of this, it really helped the team in terms of being more productive. Instead of doing all of these manual work, it's now automated. Yeah, so really amazing that with technology, things are more efficient. Okay, so given what I shared a while ago, is it possible to get everything completed in 15 minutes? Because in general, we want things faster and better. But with the scenario I shared a while ago, it's really not possible. Because with the throttling, it's so important that you do that or else you'll get blocked by the website.
So I have a question for you. So you're saying here that data scraping activity earlier, where you were scraping a website and then you have some sort of Python script to extract information there. It's not possible to get all the scraping done in 15 minutes. And you're saying that that's because the website is blocking or throttling the request because your script is trying to overload some external website. Is that correct?
Correct. So even if you wanted to aggressively push this, the website will block you from doing so.
I have another question for you. So how is this all related to our generative AI talk? Again,
Yeah.
data scraping.
Hold on. You'll see it in a few minutes once I share the next example. So let me go on to the next one. So fast forward to the present day. So right now, okay, magic in between of the session. Okay, So right now with Gen AI, now you could use RAG to augment your database so that it's now more relevant to your internal processes and whatnot, or information. And when you create these sort of Gen AI powered applications, maybe on the first try, you get like a 30-second response time. And from there, you get to improve and make it like maybe 10 to 15 minutes. But maybe some of your customers would say, or some of your stakeholders would say, hey, 10 to 15 seconds is still so slow. I want it maybe 1 to 3 seconds. So yeah, but if you want to do it like 2 to 3 seconds, but at what cost? Like, are you gonna rehaul everything just to hit that certain metric, or it's gonna be way, way more expensive than what's initially forecasted or budgeted? Yeah, like Thanos here. So there. So just a quick intro because we weren't able to introduce ourselves properly. Again, I'm Sophie Sullivan, and here with me is my co-speaker, Arv Zlat. Go ahead.
So I am Arbs. So I am Joshua Arvin Lat, and I am the Chief Technology Officer of NuWorks Interactive Labs. So we're both from the Philippines. So I'm also an AWS machine learning hero, and I authored the following books. So Machine Learning with Amazon SageMaker Cookbook, Machine Learning Engineering on AWS, and Building and Automating Penetration Testing Labs in the Cloud. So as you can see, 2 books on machine learning and 1 book on security. So next year, there will be 2 books coming out. So 1 on security and 1 on generative AI. So stay tuned. And for Sophie.
Okay. So hi again, I'm Sophie Sullivan, and I'm the Operations Director at Edamama. Previously, I was a General Manager of E-commerce Services and Dropship for a startup incubator for BeatMNL, Guild Grocer, and ShopLite. And I have a couple of certifications in cloud computing and data analytics. And lastly, I was also a technical reviewer of a book called Machine Learning Engineering on AWS. So there. All right. So since we're on the topic of Gen AI, I'll just quickly give you like an overview of some of the concepts and jargons in this sphere. So in general, people misconstrue AI with machine learning. People think it's the same. It's not the same. Machine learning is just a subset of AI. And here's like a word map of all of the different jargons in AI, just so it's clearer to see like how these concepts interrelate with one another. So here we have AI as the overarching theme or overarching umbrella. And for now, we have 3 stages under AI. So we have ANI, AGI, and ASI. So for ANI, it's our current stage wherein AI is still in its infancy, meaning whatever we're experiencing now, even though it seems so cool, it's still at the low levels where AI can simply do tasks that are not as comprehensive. And then we have AGI, which is the next level, where AI can do more comprehensive workflows and processes and whatnot. And then lastly, we have ASI, where AI could possibly be even smarter than a human being, and it could maybe solve the world's problems. And then we have ML, deep learning, and our topic for today, Gen AI. And as you know, in Gen AI, there are different modalities. So we have text or LLMs, images, audio, and even videos. So
Wait a minute, I'm a bit confused.
the gist.
Yeah, I'm a bit confused. So you're saying that AI and machine learning, they're different?
Yes.
So machine learning is a subset of the overall AI umbrella.
Correct.
And then underneath those, of course, much deeper would be deep learning, and then generative AI, where you can generate new like content or data.
Yes, yes.
Okay, perfect.
Yeah. So there. So as mentioned, we'll focus mostly on Gen AI for this session. And so, have you ever wondered how long it will take to build that generative AI-powered application? So I'll be giving you a few examples of like how Gen AI is used today. So first one is I generated this prompt or created this prompt wherein I wanted the tool to come up with an image of audience members watching a conference talk. So here, it was able to output like a real-life image of how it looks like. So it's really amazing that now we use Stable Diffusion to come up with this image. Okay, I inputted like another prompt wherein I wanted the Gen AI tool to come up with a response to this. So it says, you are a very intelligent bot with exceptional critical thinking. I have a conference talk that lasts for about an hour. I shouldn't spend more than 2 to 3 minutes per slide. How many slides do I need? So with that, it outputted this really, really long, comprehensive information, which you don't have to read through, but it basically says for like a 45-minute talk, it would be around 2 minutes per slide or 22.5 slides.
But wait a minute. Remember, our talk is just 30 minutes.
Yeah, so it should be way less than
Way
this.
less in terms of slides,
Yeah,
right?
yeah. And take these information with a grain of salt, because depending on your situation, it could be more or less. So in general, these AI tools can help guide you, but you have to have that verification or guardrails in mind to make sure that the information you get is really accurate. Because again, these things could hallucinate.
Perfect.
All right. So have you ever wondered again how long it will take to build that generative AI powered application? So just zooming in on like how long it takes. Maybe the audience here has like a guess of like how long. Then let's see who guessed it correctly. Do you have any volunteers?
Well, I could try guessing. So maybe 1 week or 2 weeks. So what's the correct answer?
Wrong. Actually, it should not take more than 6 months. But for those who are really adept in AI, it could be as fast as like 1 to 3 days for the core functionalities. But if you want to build a really scalable, high performance, secure, cost optimized application, it will take around 2 to 3 months. But in general, it shouldn't take more than 6 months.
So you're saying that if you want to get some proof of concept work completed, maybe somewhere around 1 to 3 days, and then the reason why it could take longer than a week or a month is that you have to take care of the other things like security, scalability. You should be worried about the cost
Correct.
and other things.
So there, I'll turn it over to you to discuss more in detail.
So now that we have a better understanding of so now that we have a better understanding of why it's important for us to have a good idea on what this session is all about, we can now proceed with the more technical details. So earlier, we discovered and we realized that after the first set of tasks in order to produce the POC code, let's say 1 to 3 days, we'll definitely need a bit more time in scaling and optimizing the generative AI powered applications. So let's start first with how these applications are built. There are different ways to build this. Maybe you can just integrate it with, let's say, an API existing, but it's also possible for us to deploy a large language model in its own inference endpoint. And here you can see that we have a data science environment, and the resource containing the large language model is different. And this is where it gets expensive. If you have 100 employees in your company and you want to roll out your own ChatGPT implementation, of course, without the data going outside of your environment, then it might cost you a lot if you have a 24/7 server running inside a separate resource. And of course, it's not just that. There are other components in this architecture as well. In addition to the resource attributed to the machine learning component, there are of course other non-machine learning components there, which of course would have the front-end components and the back-end components, similar to how web applications work. So you can just think of this as some sort of web application plus the AI components. And later we will see how this works also under the context where you're using RAG, Retrieval Augmented Generation. So this comes with its own set of challenges. So number one, if the server where your large language model is deployed is a bit too small because you want to save on cost, you don't want to pay a lot because there are not a lot of users using it, then it might end up being 30 seconds in terms of like the performance or the response time of your server. So let's say that your large language model is deployed inside a 12x large server, then if you were to, let's say, double the size of the server, then you will end up paying much higher cost for that. So from 30 seconds, that may end up like 20 seconds or 7 seconds. But again, the question is at what cost? is your company really able or willing to pay for that cost just to reduce the response time by half? The good news is that there are other ways to do it. So in my company, this is the exact problem that we encountered. So the first lesson that we should at least learn or know is that we should try estimating how much the entire application will cost before the actual application implementation. A lot of us want to integrate this, deploy that. The first thing we need to do is let's take a step back and see how it would impact the financial aspect of the companies. So now, what we did here is we used quantization, and we updated the deployed large language model in that endpoint, and we were able to reduce the server from 12x large to 2x large. So when you learn about these optimization techniques, there's a lot. So what I would recommend is for you to try it out. So for example, quantization. Sometimes the readily available implementations have this available already by just commenting out and allowing certain configurations to be available. So in this case, through quantization, yeah, we were able to save a lot of money. However, even with 2x large, it's still expensive. That's why we started introducing the serverless implementation. If you've tried serverless implementations before, you're basically paying for what you use, and generally per second or per microsecond. And just to quickly describe what this is, serverless is not equivalent to functions as a service. So we'll have a separate deep dive session on serverless later on my third talk on hacking and securing serverless generative AI-powered applications. But for now, just make sure that you know this. Serverless is not equivalent to functions as a service. So here, when we replace the self-hosted large language model setup, we just use an existing API. So in this case, in AWS, there's Bedrock. In other cloud providers, there's also their own counterparts. But for sake of simplicity, we'll just use AWS for now. So the good thing here is that there's no risk in terms of like implementing this, because at the start, you will be having a few users using it, and then over time, you will see more users using it. At least the cost is not fixed cost. And the service provider is the one in charge of ensuring that performance is guaranteed. So from 30 seconds, it became 1 to 2 seconds. So how would retrieval augmented generation work in this case? There's a way to implement a serverless architecture combining the powers of Bedrock and SageMaker. Is it possible for SageMaker to be serverless? Yes, with the usage of some custom Python scripting. So here we can see that it's possible to combine other more traditional machine learning models. So in this case, we created a script which makes use of two non-generative AI models. So inside that SageMaker serverless endpoint, we were able to deploy those two models at the same time. And there, you basically use it similar to other serverless inference endpoints. The difference is you're not paying 24/7. You're only going to pay it when that component is invoked. So in this case, this SageMaker serverless inference endpoint serves as the vector database. So whenever you're using vector databases, you would probably be using something which is already pre-existing. However, in this case, since we couldn't find any vector database that scales to 0 and something that fits our needs, then we basically created our own. So now you have a purely serverless scale to 0 Bedrock component, and then you have a SageMaker serverless inference endpoint that also scales to 0. What do you mean by scale to 0? When nobody's using it, then you won't pay for anything. So this is how it would output. So now we have a purely serverless architecture. And now instead of, let's say, 1 to 3 seconds, of course, there may be a few seconds which would be on top of this implementation. But again, that's much faster compared to waiting for 40 seconds for it. All right, so last part of this presentation. So if you were to add another Lambda function there, then it's possible for you to add a few seconds because you decided to add additional layers. When you're using serverless functions, every time you add one, there's the risk of what they call cold start. So here, just want to make sure that you want to keep your application as simple as possible, and you also want to monitor what's being inputted and how much traffic there is every day. So it's important for you to implement guardrails. And at the same time, you also want to make sure that you analyze the data that's going in and out of your system. So finally, when talking about security, it's important for you guys to know that when you add additional security measures and components in your architecture, you also have to measure how much time those security features would take. So for example, in this case, you want to secure the processing of the input request. So here you introduce an orchestration layer. And instead of passing all the data to a single large language model setup, it's possible to have two. Meaning, if there's untrusted input, then you can pass it to the quarantined LLM. So for more details on this, we will have this in the third talk on hacking and securing serverless generative AI-powered applications. So that's pretty much it. And we actually have a second talk later.
Yeah, at 2 o'clock.
At 2 o'clock. But for now, that's the first presentation. So thank you so much and hope you learned something new. So any questions? Yeah, go for it.
Before I want to ask you something, because you just arrived and I know you're from Egypt,
Oh.
so magandang hapon.
Yes.
Magandang
I'm just curious about how you handling the support in AI, because in web development, it's totally different with AI, right? If our user using AI, it requires real-time response, right?
Yeah.
Yeah, how to handle it when the server may be busy and user need to fast response.
Yes, thank you for that. So, yeah, so there are at least 3 answers I could give you. Okay. So there's the real-time option. So similar to how you use ChatGPT. The data is passed back to the user even if it's not yet finished. So there's streaming option. Yeah, so there's the streaming option. So it's not included here because the example here just assumes that the serverless solution is able to provide the entire chunk of output in just 1 to 3 seconds. Okay, and that's the second option. So first option is streaming. So if you're able to use something like Bedrock plus the GraphQL service, like what's it called AppSync. So AppSync plus Bedrock. So there are a lot of blog posts there. So you can adjust your solution so that the API that is talking to your front-end components, it's able to communicate, and that GraphQL API, it's not necessarily needed to be GraphQL. It can be any sort of API. So streaming API, that's the proper. So streaming API is connected to your serverless generative AI implementation. So you can technically have some sort of like rope. So these components are all connected with each other. And instead of waiting for the entire chunk of output to be returned back to the front end, then it's possible to pass this by chunks. And in addition to that, the architecture here is very simple. You just simply assume that there's one large language model. Once you have multiple generative AI components there, once you have a chain, it gets a bit more complicated. So when you're using that type of implementation, it's important to measure how long it takes for each component to complete processing a response. So at the start, when there's only one user, then it probably works fast. However, once you have a lot of users, how do you manage all of this? It's important to have guardrails and guardrails provided by the services and implement your guardrails yourself. So I'll repeat that. This is the most important part. When implementing these types of architectures, it's important that you're able to implement guardrails yourself. For example, counting the number of times a user has accessed your APIs, and then blocking them, and then letting them know that they can use it after, let's say, 24 hours. Because it's also possible for your implementation to be bombarded with a lot of requests. So even though this is serverless components, even though they are virtually scalable, there's, of course, that maximum threshold, especially when you specify that. For example, you can have a maximum number of Lambda functions running. So if that limit is reached, then all your other users would be affected. So you also need to analyze the maximum number of invocations in every component that you have in your architecture, because it's different when a lot of users are using it all at the same time, and when your application hasn't been invoked for, let's say, 20 seconds to 30 seconds. Because there's also that concept of cold start. So let me know if I was able to answer that question. So thank you so much. Yeah. Yes, so there. So we're actually running out of time. And if there are more questions, we actually have a second and a third presentation. But feel free to visit the other sessions, as there's a lot of amazing sessions here in Pycon. So thank you so much, and hope you learned something new.
Thank you again, Mr. Joshua and Ms. Sophia Sullivan, for answering the questions and for your insightful presentation. That was an insightful talk, and please give a round of applause to our speaker today, Mr. Joshua and Ms. Sophia Sullivan. We hope you found it insightful and today and enjoyed for your presentation. Thank you so much.
I just had that income. What if that happens?